All right, hello and welcome. So in this video, basically we're going to be looking at more factoring problems. So using the same methods we did last time, but with a couple of like special cases. So the first thing I'm going to look at is 16n squared minus 9. So last time when we saw the ones with only two terms, there was some sort of common factor between the values. Unfortunately, this time there is nothing that divides from both 16 and 9 equally. Um, so before I give up on this question, I'm going to treat this like the trinomials and try to use that box method like we did on the second set of problems from the previous video. So I know that when I'm setting up my box, I'm going to start with 16n squared, and I'm going to end with minus 9. The trick to this, though, is that even though there's nothing in the middle, I can pretend that they gave me a 0 n as the middle term. So what that means is that when I'm looking for my two missing terms inside the box, I'm looking for things that cancel to 0. So just like in the last video, I'm going to take the 16 and the negative 9 and multiply them to 144. And I'm going to think of things that multiply to 144 that could subtract to 0. And now, the first thing that comes to my head is that 144 is 12 times 12. And so, if I want to make a 0n, all I need to do is take 12n minus 12n. So I'm going to fill in my box. And then I'm going to factor. So if I go across the top row, I see n's in both terms. So I know I need an n in the front. I know that 16 and 12 will both divide by 4. And now I'm ready to finish out the problem. So if I see 16n squared on the inside, 16 divided by 4 is 4. I see n squared on the inside and n on the outside, so I know I'm missing the n. In order to get the negative 12n on the right-hand side, I need another negative 3. And then as I go to the bottom, to get the 12n on the bottom, I need a positive 3 here. And again, if I did this correctly, the positive 3 and negative 3 should multiply to make the negative 9, which it does. So my two factors are 4n plus 3 and 4n minus 3. This is called the difference of squares. Because my original problem, I had a 16n squared and a minus 9. Both of those have square roots, which we see in the 4 and the 3. And since I'm subtracting them, that's where the word difference comes from. All right, so let's look at a second example. There's going to be a similar pattern to this one than there was to the one that we just did. So I'm going to set up my box. Once again, I know that I start with 16b squared. I end with plus 25. And I know I have two missing numbers that add up to negative 40. So just like last time, I'm going to take 16 times 25 because those are my numbers on the outside. That's going to give me 400. So trying to come up with numbers that add to negative 40, I know 400 is equal to 20 times 20. I know that if I add those, it will give me 40. So if I want negative 40b, I'll just make it negative 20 and negative 20. So if I put minus 20b in both of my missing spots, now I have everything set up. So once again, we're going to factor. So I have b on both terms, so I know that comes out. 16 and 20 will both divide by 4. So there's my greatest common factor. If I see 4b on the outside and 16b squared on the inside, 16 divided by 4 is 4. I need an extra b to change the b into b squared. I see a negative 20b on the right, so if I do negative 20 divided by 4, it gives me a negative 5. On the bottom, I see a negative 20 again, so negative 20 divided by 4, also negative 5. And then if I multiply my negative 5s, it gives me a plus 25, so I know I've got it set up correctly. So when I go to write my answer, I notice that the numbers on the side and the numbers on the top are the same. So I know that I'm going to need 4b minus 5, but instead of writing down the same parentheses twice, I'll just put an exponent of 2 because that tells me that I'm multiplying the 4b minus 5 again. And so because we factored our trinomial and got the same thing twice, we're looking at what's called a perfect square trinomial. And so in this example, we're going to see what happens when they give us 4 terms to factor. So if we look at the terms, once again, there's not a greatest common factor because I don't see matching variables in all 4 terms. And I don't see like a one number that I can divide from 35, 5, 56, and 8. So that tells me that I want to set this up like the ones we just did. Right, which means I know that I'm going to start with 35xy. And I'm going to end with positive 8. However, unlike the ones we just did, they actually gave me enough terms to fill in the box. Right, so I don't have to figure out what goes in the middle. I already have it split up. So all I need to do is write down the 5x and the 56y. So from here, the factoring works exactly the same way as what we just did. So when I look at my top row, I see an x in both terms. And I know that 35 and 5 will both divide by 5. If I take the 35xy and divide it with the 5x, I know I need an extra 7 up here and an extra y to get the 35xy on the inside. Then when I look at the right side, negative 5 divided by positive 5 will give me a negative 1. And it looks like the x's already match, so I don't need another x on top. When I go to the bottom row, right, negative 56 divided by 7 gives me negative 8. The y's already match, so I don't need any extra y's on the outside. And if we set this up right, negative 8 times negative 1 should give me positive 8, which it does. So my factors for the final example are 5x minus 8 and 7y minus 1. All right, that's all I have for this one. I will see you guys next time.